Hi there guys, what we are going to be looking at today is a little bit of algorithms, some computational thinking, some searches and sorts, and some more fun computer science stuff, so let's get going. So first thing we've got here is, this is taken from an exam question, so what do you understand when you see the following? So we've got 1.4 gigahertz processor speed, 2 cores, 4 megabytes cache. So we could think about straight away how fast this is actually run, so 1.4 times 2 gives us 2.8. So that's going to be the speed that it runs at, because it's dual core. We know it's dual core because we've got 2 there. If it was a quad core, we'd get a 4, and then that would obviously run quite faster. This cache size here as well, remember the cache is what stores information, frequently used instructions from the CPU. So again, if this was then at 8 megabytes, then more information would be able to be stored in the cache than it could be retrieved by the hard drive quicker and sooner. So that's just a nice little bit of revision for you right there. So we have got 3 terms here: abstraction, decomposition, and algorithmic thinking. And these 3 words are really important. So let's first of all kick things off with abstraction. It's about focusing on the important information only, ignoring the irrelevant details. So if you've got an exam question where we're saying that Bob has got to get some carrots, some tomatoes, some peppers, and some sausages, you'd think that that is pretty important information, pretty relevant information to have. But if it's just saying what's Bob going to be doing, all we want to know is that he's going shopping. It doesn't matter about the carrots, the tomatoes, the peppers, the sausages. So abstraction is focusing on the important information, ignoring the irrelevant detail. Then if we're thinking about decomposition, decomposition is about breaking things into tasks. So if you've got one big project that you need to get done, you could think, oh god, that's too much, I can't get it all done, they've not got enough time. What decomposition does is it breaks it down into smaller chunks for you to work through. So then by breaking it into smaller chunks, it's more manageable. So instead of having one big thing to do, you've broken it down into 12 things. And when we're thinking about algorithmic thinking, it's about developing a step-by-step solution to solve a problem, or the rules that's needed to solve a problem. And we'll have a look at some algorithms later on. So what I want you to do quite quickly now for me is if you click the good old pause button, and then I want you to write down what abstraction, decomposition, and algorithmic thinking are. Give some examples that you've covered throughout your GCSE computer science course. So give the pause button a press, and then we'll crack on. Okay, so now we are going to first of all look at binary searches. What binary searches are is a way of looking and finding a particular piece of information. So you can see that here we've got a load of information, and I want to say find the number 4. Okay, so all I'm going to do is I'm going to find the middle value, which is here, 22. Is 4 greater than or less than 22? It's less than, so I'm going to be looking over here, so I'm then going to discard the rest of this. So then I'm going to go for the middle value here, and here we've got number 4, so I found it. Fantastic. If I was, for example, going to go for a different value, say I was going to go for, if I'm going to look for the number 1, sorry about that. So once again I'm going for 22, eliminate these. I'm then going to go for the halfway value. We're going to look at the number 4 here, so then we can get rid of these, and then I found the number 1. If I've got a longer list, so if I just draw out a longer box here, and let's just put some numbers in here, 2, 4, 6, 8, 10, 12, 14, 16, and 18. Again, I'm going to go for the middle value, which will be the number 10, and I'm looking for the number 16. So is 10 less than or greater than 16? It's less than, so I'm going to be looking over here. So then straight away I'm going to get rid of this section here, and I'm then going to go to number 14. And is 16 greater than or less than? It's greater than, so I can then get rid of these ones here, and then I'm left with 16 there. So what this does is it cuts things down and chops things down in half as you go along. So really effective if you've got a large data set, but it must be in a sorted list. If it's completely odd numbers and it's not in any order, a binary search won't work. Binary searches, you've got to have things in order first. So it's got to be in numerical order, or you can even have it in alphabetical order. So if you had Adam, Bobby, Charlie, Derek, in that organized alphabetical way, again, you could do a binary search on names. And if they weren't in an organized name, then a binary search just wouldn't work, 'cause it wouldn't know what it's looking for. Then we've got a linear search. So linear searches will go from one box to the next box, 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 until you found something. So if I'm looking for the number 22, one step, two step, I found it. Fantastic. It's in this box here. With a linear search, it doesn't have to be in order. So again, if we just draw out another box, I promise my art skills will get better. 2, 16, 5, 19, 27, 16 again, and 3. And I want to find the number 5. So I'm going to look here. Is an art here? No, it's not. Let's go to 16. Is it 16? No, fantastic. It's 5. I found it. With a linear search, if you've got a small amount of data, as we can see here, it's quick. But the more data you've got, the more searches you have to do it in. Linear searches as well, they don't have to be sorted. You could just grab any piece of information you want and do a linear search on them. So what I want you to do in your books is I want you to explain what binary and linear searches are, how they work, and when they should be used. Also remember to include if something is sorted or not sorted, which search would you use. So give the video a quick pause, and then we're going to move on to some sorts. So here we've got 5 numbers, 5, 1, 12, minus 15, and 16. And they're not sorted, as we can see. What a bubble sort does is it compares 2 values and then swaps things around based on those 2 values. So for example here, we can see 5 is greater than 1, so it's moved its position. 5 is less than 12, so those 2 are okay next to each other. 12 and minus 5, it's not working, so then it's going to switch those 2 round, and then 12 and 16 is fine. So this is what is called the first pass. So we can see here that we've just looked at the values going through, and then we're going to start again. 1 is less than 5, so that's 5. Fine. 5 and minus 5 aren't the way around, so we're going to do a little switcheroo. 5 and 12 is fine. 16 we know is the largest number, so don't have to worry about it. Then we're going to have a look again. 1 and minus 5, because minus 5's now moved down into this new position. We need to switch those round. So then minus 5, 1, 5, 12, fantastic. And then this last one here is just a little check. Minus 5, 1, fantastic, everything's sorted. So you can see here, it goes down sequentially. So we've had 4 comparisons here, 3, 2, and then find the last one just to check everything's okay. So if we had more numbers in here, so if we had the number 27 here, it's going to take more time to go through it. So bubble sorts was comparing the 2 values and literally swapping them around to see what needs to happen if they need to be sorted around or not. We've then got merge sorts. And what we've got here, again, is another unsorted list. And we're just going to cut the values in half. And then those ones are going to go over there. These ones are going to go over here. And we're just going to keep breaking them down until we get to this point here. And you can see here now, these are all individual numbers. When they get put back together, this section here with the green arrows, this is when the sorts are happening. So then it's put into order for 27 and 38 instead of being 38 and 27. Instead of being 43 and 3, because they're separate values, they can be looked at and put together again, and so on and so on. Then when they get to this next level here, there's a sort done on these 4 numbers and they're put together, and again with these numbers and put together, and then finally on this final level here, they're now all in the correct order because they kept getting sorts. So it's called a merge sort because everything gets broken apart in this section here and then gets merged together down here. Final sort we're going to look at is an insertion sort, and there's lots of GIFs available to show you about insertion sorts, but I couldn't find one which worked happily in my PowerPoint, so I'm going to give you a quick demo now. Suppose that we have got this list here. We are going to go 26, 15, 9, 17, and 6. Obviously this isn't a sorted list, but what an insertion sort does is it takes the variables and then it puts it into a separate list above or below, and then everything gets performed up here. So we don't worry about 26, but we can see that 15 needs to be before 26. So 15 comes out, 15 gets put up here, and then it gets inserted at the start of the list. So then we've got 15, 26, nothing there, 9, 17, 16. So then the next time round, we've got the number 9. that needs to go at the beginning of the list, so then we'll pop it just here. Same thing will happen again. We've got 17. We'll put that into a fresh list, and that will need to get put into here. And then finally 6 will get taken out, put into a new list. It will look for where the values need to go, and then get put here. So with an insertion sort, it creates 2 sets of lists, and then the variables get taken out of the first list, and then reorganized and reinserted into a second list. So again, if you've got lots of values, it's going to take quite a while to do. So what I want you to do is give the video a quick pause, and I want you to explain bubble sorts, merge sorts, and insertion sorts, how they're used. And also remember, with a sort, the whole idea of a sort is that it's organizing things into some sort of numerical order, or as I've mentioned earlier, alphabetical order. So give the video a quick pause, get those done, and then we're going to go create some flowcharts and pseudocode. So here we've got an example exam question. Create an algorithm using either pseudocode or flowcharts, which will take 3 numbers, decide which number is the largest, output the largest number. Main thing to remember when you're doing an exam, if it says using either pseudocode or flowcharts, you can create either. But if it says using pseudocode or using flowcharts, you've got to go with that. If you create an answer to this and it says using only pseudocode, you need to use flowcharts, you won't get any marks. So what we're going to do is we're going to look at it in 2 ways. First, we're going to look at it as pseudocode, and then we're going to create a flowchart about it as well. So first thing we need to do is be able to take 3 numbers. So I'm going to go for num1 equals input, num2 equals input, and num3, you guessed it, equals input. And remember to do it this way around in the exam, because this is the variable that you're creating, and you're using input on it. So that one there is done. Decide which of the numbers is largest. So then we've got to do some if statements. So we're going to say if num1 is greater than num2 and if num1 greater than num3, output num1. Remember, we're using the term output here because print, which most people would originally use, could be command line or programming language specific. So output is a generalist pseudocode term for displaying things. So you can see where we're going to go with the other if statements, and then we've got the output, the largest number, that bit there, that's sorted out. So if we're going to represent this as flowcharts, again, what we're going to do is going to start off with a start, and then we're going to have a series of shapes. These are going to be used for inputs, but I'm just going to be using shorthand for now, using the letter I. Don't do that in your exam because you won't get any marks for it, or they will just be like, what's going on here? So these 3 here are asking for the inputs. So that's that first one again done. And then we're going to use a series of decisions. So is n1 greater than n2? And then we can go down here, is n1 greater than n3? And we can go down from there. That's one way of tackling with the flowchart. Another way of doing it is having your 3 inputs, and then instead of having this decision here, having a process, and inside that process have n1 equals L. So then that L there represents largest, and it's a variable that you can keep track of. So there's 2 different ways of going around and solving that. We've got another one here, and remember, if we're looking at this question here, I can only use pseudocode. So if I create a flowchart, I'm not going to be able to get any marks for it. So I'm asking for 2 numbers, produce the results of addition, subtraction, division, multiplication of the 2 numbers, and outputs each of the numbers with a suitable message. And that suitable message line means you can't just write output number, you've got to say output addition number is, so then it makes sense. So if your mum came along and looked at your pseudocode, she'd know what's going on. So the key things to remember here is that we've got to ask for 2 numbers. So once again, we're going to go num1 equals input, and we're going to go for num2 equals input. So even if you don't know how to do the rest of it, you're still going to pick up a mark just by doing this section here. So what we need to do now is produce the result of the addition, subtraction, division, multiplication of the two numbers. So I'm going to just call it addNum equals num1 plus num2. We're going to go for subnum equals num1 minus num2. We are going to go for divnum equals num1 divided by num2. And then we're going to go for mulnum equals num1 multiplied by num2. So now we've got that section there sorted out. And now we output each of the numbers with a suitable message. So you would need to write this down here, but I'm just going to go over here because I've got more space. So I'm going to go output addNum is, and then I'm going to go for addNum. And then I can do the same again. Output subnum is subnum. And again, you can see if I was going to write this in Python, I'd have a comma there, I'd have that there, I'd use print instead, but you don't do that with pseudocode, because pseudocode you need to be able to take and translate and then use with any other language. So we'll have a look at one more scenario. And here we've got ask an animal to be input. The program should then output if the animal, if it has 2 legs, 4 legs, or no legs. The program should cater for at least 5 animals. And I can either use pseudocode or flowcharts. So in this video, I am going to go and use pseudocode because I prefer using pseudocode personally. But if you want to use flowcharts, be my guest for it. So first of all, we need to ask an animal for input, and you've guessed it. I'm going to do animal equals input. So again, if this is an exam question, you will have hopefully picked up 1 mark by making sure you're inputting. We've then got this part here. The program should then output if it has 2 legs, 4 legs, or no legs. So I'm going to create an array called 4legs, and I am going to put into it dog, cat, lion, elephant, and let's go for a horse. I'm going to create another one called 2legs. And I'm going to put in there human. Yes, we are animals. And I'll also go for Ludicolo. I know Ludicolo is a Pokemon, but this is my video. I can do what I want. And I'm going to create another one called 0legs. And I'm just going to put in there snake, because snakes don't have legs. So what I can now do is I can check these arrays to see if anything's within them. So I can say if animal is in 4legs, output 4legs. So what I'm saying is if the animal, which is what we've got here, is in the 4legs array, output 4legs. I could also write as well, I'm just going to do it over here, but you do it underneath it. If animal is in 2legs, I could go output 2legs. To make it even better, instead of having an if, I could go for elif, and then I could go for elif animal is in 0legs, output no legs. But what if I write in, for example, dragon? Dragon isn't in my 4legs list. It's not in my 2legs or my 0legs, so I'm just going to go for else unknown. So by doing this section here, I'm putting some data checking in there to see if it's going to be in there, because if it's not in there and they don't see any results, then the end user might be a little bit confused, to say the least. So the list there, I'm talking about it all the time. So I hope this video has been helpful for you. I hope you're more happy about this sorts of areas, and I shall see you in another video. See you later.